Good morning, good afternoon, depending on the time zone in which you are. On behalf of my colleagues and co-coordinators, Diana Mendez, Pedro Urquijo, Alfredo Pureco, Timothy Lorek, and Antonio Chamorro, I welcome you to the Interinstitutional Global Seminar on Green Revolution, an academic space supported by the Colegio Mexiquense, the Dr. Jose Mario Luis Mora Research, and the Environmental Geography Research of the National Autonomous University of Mexico. Well, it's a pleasure to have you present today in this sixth session of this seminar, and we are going to discuss about the Green Revolution in India. Well, but before of beginning this sixth session, I have to say that one of our speakers, Corinna Unger, had to withdraw because, well, she's ill. So, well, unfortunately, it's something about that these things happen. So, well, with that said, I'm going to give the floor to the moderator of the session of today, Carlos Mondragón, to whom we are very thankful of being here today. Well, Carlos Mondragón, the Professor Mondragón, has a PhD in social anthropology by the University of Cambridge, and actually is full-time professor at the Center for Asian and African Studies at the Colegio de México. Well, Professor Mondragón, go ahead, please.
Thank you, Nezahualcóyotl. Well, I'm very pleased to be here as well. I'm actually quite honored to moderate this panel with such an interesting range of scholars working in a region that I don't specifically specialize in, but is neighbor to the places where I do specialize very closely, actually, in some cases. So I think we'll just get to it. This session, I seem to remember this is number 6 of the 13 sessions, and it's dedicated to South Asia, or more specifically to India. And so I'm just going to go ahead and introduce Gabriela Soto Laveaga, who is our first panelist. She's professor of history of science and Antonio Madero professor for the study of Mexico at Harvard University. Her current research interests interrogate knowledge production and circulation between Mexico and India, medical professionals and social movements, and science and development projects in the 20th century. Her first book, Jungle Laboratories, won the Robert K. Merton Best Book Prize in Science, Knowledge, and Technology Studies from the American Sociological Association. And her second monograph, Sanitizing Rebellion, Physician Strikes, Public Health and Repression in 20th Century Mexico, examines the role of healthcare providers as both critical actors in the formation of modern states and as social agitators. Her latest book project seeks to re-narrate histories of 20th century agricultural development aid from the point of view of India and Mexico. And I was reading some of the materials that Gabriela sent us prior to the panel, and I found them quite interesting. Indeed, she has held numerous fellowships, including those from the Ford Mellon, Fulbright, DAAD, and Gerda Henkel Foundations, and the Institute for Advanced Study at Princeton. Gabriela, the floor is yours. Thank you very much.
Thank you so much, Carlos, for that really generous introduction. And thank you for the organizers for the invitation to be here with you today. I'm really honored to be sharing this panel with both Marci and Rajeswari. I'm looking forward to the conversation and to the questions. So I'm just going to jump right in, and let me just share my screen. Okay. So I wanted to talk about how do we narrate wheat histories of Mexico and India when we have such a dominant narrative that with this life-size, here's a life-size image that I use often when I'm talking about Mexico and India. And I don't start in India, but rather I start here, which is in an experiment station in northern Mexico in Sonora. And what we see here is a monument to Norman Borlaug at the entrance of the experiment station with all the flags of the world where wheat that was developed in this experiment station, where those seeds ended up. And in the back of the statue is 1/3 of Norman Borlaug's ashes. And I like to begin with this image because it really shows how much the narrative of Borlaug has dominated so many of the histories of the Green Revolution, but also how even in death, with the ashes there at the back of the statue, we still have this larger than life presence in the past and even the histories that continue to be written. So what happens when we move beyond those narratives and focus on two countries, Mexico and India, without focusing on the key aspects of how we have learned to narrate the Green Revolution? So today I'll show you a bit about what my research, which thankfully I'm finally finishing the book, this is a preview of what that is looking for. So I really am trying to move beyond the Borlaug story, and which is very difficult because so much of the narratives are based on him, and even the narratives that have continued to come out in the last few years, even though he may not be as prominent, he still is the pivot for many of the stories about the Green Revolution. So how do we move beyond Borlaug, which is one of the articles that I recently published, and get to, when we move beyond Borlaug, it's not so much about the methodology of how we do it, but what stories emerge when we do so. So also when moving beyond Borlaug, we also need to move beyond the map, the Mexican Agricultural Program, and begin to look at the sites in both Mexico and in this case, India, that were already on the ground when either the map comes into Mexico or the Rockefeller Foundation arrives with Norman Borlaug and seeds to India. So just to put a little bit of historical context, in 1963 and 65, the IARI, or the Indian Agricultural Research Institute, assisted by the Rockefeller Foundation, introduced from Mexico a selection of wheat varieties containing Norin dwarfing genes, meaning that the wheats that would emerge would be smaller in size and they would not fall over, they would not lodge. In June of 1965, after some experimentation, two varieties come out to be the two most important ones that yield the most on Indian soil. And those are Lerma Rojo and Sonora 64, both of whom are coming from that experiment station that I showed you at the beginning. And so Lerma Rojo and Sonora 64 are selected to be part of a major agricultural development program for the fourth five-year plan in India. And it's based on the success of these two varieties of wheat that there's a decision made by the Indian government to import 250 tons of Lerma Rojo and of Sonora 64 from Mexico. And in November of 1965, an additional 18,000 tons would be imported for November of 1966, 1 year later, making it the largest export of wheat coming from Mexico up until that point. So some of you, I'm sure, are familiar with these images, which is the wheat that is being put onto these ships that are being at the port of Guaymas in Sonora, and they are going to sail to what was then called Bombay. So here is a photo, and these are from the Rockefeller Archive Center. You just can see the amount of wheat that is being sent from Mexico to India. And I really love these wheat sacks and how they're titled, because they are going from Mexico, and Mexico sees this as an India supply mission. And what you see here is that the seed is going from Hermosillo, Sonora to Mexico. Together with these photos in the Rockefeller Archive Center, I also found the photo that you see here on the bottom corner of a Mexican family. And the idea was that Mexico was feeding the world. And the way it was doing so was not just simply with crops, but with the seeds that would go on to transform farmlands around the world. So this is really important to me, that it's an India supply mission, and it's the Lerma Rojo that was required, each one 75 kilograms, but the most important thing, that it's coming from Mexico. I want to underline that because this narrative will be overshadowed by the histories of the Rockefeller Foundation and later the Ford Foundation, where Mexico and its contribution, especially in these initial years, is really edged out. So when we talk about the seeds traveling from Mexico here to India, and I really love this map because it shows just how the microclimates aligned from Sonora, which is around here, to the Punjab, and Delhi, which is around here, a little bit lower for Delhi. And so these seeds, Lerma Rojo and the other seeds coming from Sonora, were meant to be successful because you had very similar climates in both of these spaces. So in 1966-67, the high-yielding varieties program was implemented in select districts in India, and approximately 500,000 hectares of the best wheat land were sown with these seeds, the Lerma Rojo and Sonora 64. But there was a problem with these Lerma Rojo in particular because of the red tint. So scientists in India decided to, with gamma rays, radiate the seed so that you would have a wider product, a brighter bread product. And what became the Sharbati Sonora became the most popular seed in 1967. And that really is a coming together of what Mexican scientists and what Mexican farmers had been developing in Sonora and the needs of both the Indian people and the capability of Indian scientists to be able to tweak these Mexican seeds to create something new. So what happens when these seeds arrive to India? So a lot of seed would be needed. And this is something that I have written about previously, and it's the village of Jaunti, which is selected to be a seed producing or seed multiplication village. And the idea was that IARI would prepare this particular village in Delhi state, and it would specialize in seed production, meaning that, it wasn't done randomly. There were several villages that were considered, but Jaunti's farmers were considered to be ahead of surrounding farmers and that they were experienced in experimenting with a variety of seeds. So Jaunti becomes like a prototype village in which these seeds that were imported from Mexico will be planted. And the idea is that seed production will soar. And Jaunti becomes incredibly important. And Indira Gandhi will visit Jaunti. And in February of 1968, she says the following: the discovery of a new seed variety stirs rural people as does a spacewalk or a transplanted heart, the more literate classes. Farmers today walk miles to buy seed. The great problem for the government is to find sufficient seed and fertilizer to meet their demand. What a change from the days we could not get them to hear us or look at what we had to offer. So this notion that the literate classes are excited by spacewalks and transplanted hearts, whereas farmers are excited about seeds, gives us a real interesting sense of what are considered these dual technologies and how they're being framed, not against each other, but that the farmers are occupying a different space in the Indian imaginary at this time. So a lot begins to be written about this Delhi village, Jaunti. By 1967-68, most seed in Jaunti was high-yielding varieties, with an incredible loss of local varieties. Because these seeds were so successful, by very, very quickly, within just a matter of a couple of years, the majority of wheat seed that was being planted in Jaunti really are these Mexican varieties. So that's a little preview. So how do we think about India when we're narrating, when we narrate the Green Revolution from India to the world? But most importantly, and this is what I'm interested in, how do we narrate India when we talk about the relationship between Mexico and India? And to do so, I have turned to the memos of Octavio Paz, who is in India when all of this Mexican seed begins to arrive into the city, into the country. And Octavio Paz turns out to be a keen narrator of a country in transition. And in his memos, he specifies how Mexico feels an incredible affinity for India. In the early years of Mexico's presence, Mexico is the first Latin American country to acknowledge India's independence. And very early on after independence, they make a big fanfare of gifting a garbage truck, which it might seem like something small, but it's incredibly symbolic that it's a country that is aware of the urban issues. And it's not a showy gift. It's rather something that is practical and needed. But they also will gift a series of schools that are, they can be built up. They're sent stacked and then they flip open. And there's a host of series of cultural exchanges and museum exhibits. And what's interesting when we begin to look at Paz as a narrator is that we begin to get a very different view of India than the one that the Rockefeller Foundation and Norman Borlaug are showing us. So if we remove this narrative and we begin to look at India, not via the US or the Rockefeller Foundation or Borlaug, what we begin to see is a story that begins to emerge between Mexico and India, not of looking for differences, but rather about looking for that is familiar between Mexico and India. And what Octavio Paz begins to tell us is that to examine a post-colonial nation like Mexico, that it had something that was so familiar and a great affinity to then be able to understand India. So this is not unusual. Before Paz arrives in India as ambassador, he already spent much of his literary life pondering the meaning of colonialism on identity, of history as a tool to deflect national doubts about progress, etc. And he's going to transplant all of this knowledge that he has been pondering and thinking and ruminating about Mexico to India. And he's going to pair this up with the idea of these seeds that are arriving. So the story that we get of India at this time is more sympathetic, less harsh than that of India as seen through the eyes of technocrats, who often used economic measures economic progress as a measure of success. So Octavio Paz begins to use not developmental parameters, because if we did that, India would lag behind, but rather what he begins to use is cultural parameters. And this is really important, because what he will then see when it comes to the seeds that are coming with the Green Revolution are not linked to development ideas, but they're linked to the continuity of and the progress of a nation that is a new nation and a nation that is moving forward. Very, very different parameters for understanding success. So just to emphasize, instead of an economic or political lens, what we get from Paz, and that is how Paz is showing the Mexican government and Mexico to see India. He's teaching Mexicans and he's teaching the Mexican government how to see India. And not surprisingly, it's a very similar lens that looks very similar. Sorry, it's very similar to how Paz is understanding Mexico. It's a discourse of a country in transition. And what kind of country will emerge will depend wholly on the countryside and what's happening in the cities. So one could argue that India was a pivotal space for Paz to hone his skills as both an essayist and a critical thinker of the soul of a nation. And in reading his memos, that's exactly what he's doing. In 1950, Paz had written what is probably one of his most important works, which is The Labyrinth of Solitude, which is an existential rumination on the character of Mexicans and Mexico. And he's going to apply this same rumination to think about seeds in India. So, for example, his memos will contain texts that really bind India together, where he's saying here, for example, there's great sympathy between these two countries. Both Mexico and India are countries that have a rich past. They have both been the birthplace of extraordinary and original civilizations, and they are moving toward social reform. And it's not going to be an easy move towards social reform, but agriculture is going to play a big part. So the memos of Octavio Paz begin to speak also of hunger as a natural catastrophe and a political construction, but he challenges what a natural catastrophe is and really looks at how hunger in India, as all of you on this call know, this notion of a created hunger through British colonialism, begins to untangle what it means to have a natural catastrophe in a space that has been subjected, like Mexico had been, to empire. And he's going to try to place this also within the context of the relationship between India and Pakistan and India and China. So basically giving this much larger view of an India that we normally do not tend to get when we're looking at the Rockefeller coming into this space, but rather focusing most often on the seeds. And so you begin to have at this time that in the mid to late 1960s, that a series of articles like India looks forward to closer ties with Latin America, or I can't see this because of this controls here, but also these other titles. And the idea is that we can circumvent a world where the two superpowers in a war, in a Cold War moment, what would happen if India and Mexico, or India and Latin America, were to come together? And so Mexico is doing a series of overt actions toward India. For example, in October of 1962, Nehru, here we have Nehru with Lopez Mateos. Oops. There's a very important traveling Mexican exhibit that goes to Calcutta, Madras, New Delhi, and Bombay in 1965. And it's not only showcasing the wealth of Mexican culture, but also finding parallels with the Indian with the Indian past and India's present as well. So if we move outside of the experimental stations of northern Mexico and the experiment stations of northern India, what we begin to see is a much more complicated and really interesting view of an India that is being embraced by Mexico, but an India that's also wanting to embrace Latin America. And it's at this moment when you have this fostering of relationships between these two regions of the world that the seeds arrive into India. I've written about this in other articles, and I'm just putting them here. But the one that I want to focus on right now is Beyond Borlaug's Shadow, how to talk about or how to re-narrate the history of the Green Revolution if we focus on the memos of Octavio Paz. And to focus on the memos of Octavio Paz, we also then begin to look at other relationships of Indian scientists with in Mexico's past. And here we have Cancoje in his laboratory in Chapingo, the National School of Agriculture in 1928-29, where he's developing hybrid maize. And to get to the stories of that go beyond the Rockefeller Foundation and that go beyond Borlaug, it's to look for these individual stories, such as this one with Dr. Savitri Sani, who's the daughter of Pandurang Cancoje, and who kept all of his papers and all of these really important articles that were coming out at his time to begin to, and it's these this archival material that she has that will allow us to tell these stories. But it's also about interviewing the Indian scientists on the ground who may not have been there in the 1960s, but who are able to remember and discuss the importance of creating this this relationship between Mexico and India. So if we move beyond Norman Borlaug and we get to this space in Punjab, where I'm going to, and if we look at, sorry, my apologies. There we go. This is where I was wanting to get. I'm so sorry, these were not the issues. But if we move beyond the experiment station in Mexico and this experiment station, this Krishi Vigna Kendra in northern India, what we begin to see is a very different story of these seeds, where it's not just about the importance of these high-yielding wheat seeds, but it's about the progress of individual villages and the progress of individual villages in these communities and what that meant. So moving beyond the wheat and moving beyond the seeds, but looking at the social, economic, and political context of these villages, we begin to see an India in transition at the most local of levels in which these seeds come to transform the space. I have about 2 minutes. Is that okay?
Yeah, I think we're good, Gabriela, especially because one of our panelists is not going to be present. We're okay. So if you want, I'm just gonna jump in and say take another additional 5 minutes if you want.
Okay, so I'll wrap up here. But thank you so much for that. So I want to go back to this slide and this notion of how we think of the India supply mission in terms of when we think of it from the perspective of Octavio Paz, who begins to write these memos about hunger in India. But he also begins to challenge from 1966, when the seeds arrive, how this narrative is taking place in India and beyond. Because very early on, this notion that the seeds come from Mexico, that's erased. And what he begins to narrate very craftily, and because he is a thinker, he needs to leave this written knowledge in these memos because he knows they will end up in an archive. And he says, Mexico is losing the narrative of as a country who can provide food for the world. And instead, what we're seeing is Mexican seeds that are now being called Borlaug seeds or Rockefeller Foundation seeds. And Mexico is being erased from this narrative. And this, for him, pains him the most when he goes to the celebration at the Yari, where they unveil a commemorative stamp about what the Indian Agricultural Research Institute did with regard for wheat. And the stamp, which has the turret of the Yari on the front, he later goes back to his office and he says, we've lost the narrative of the contribution of Mexico to India. And instead, what we are finding is that this is a project not about trying to forge relationships between two countries that have similar pasts, but rather it's a story about development. And it's a story about development aid. It's a story about progress through a capitalist system, and that can only fit within a narrative of a capitalist system. So gone are these narratives where it's Mexican farmers working to change the world far away from Sonora and in the farmlands of the Punjab. And instead, what we get is technocrats and scientists on the ground. And even within these, I'm not even going to go forward because I'm afraid of what the image is, because these are now out of order. My apologies for that. For Mexican scientists like Ignacio Narvaez and others who don't quite make it into the official narratives. And if they do, they're just a descriptor, but not the main character. So just to wrap up, what do we learn about India and Mexico in this time period? We learn several things. Number one, that there was an attempt to re-narrate from the get-go a very different story of how the seeds arrive to India. This is incredibly important because if we had started with the Jaunti village as a narrative, or if we had begun with Octavio Paz as a crucial pivot to how we tell the stories, we would have a story of collaboration and cooperation, and not a story where it's just the export of these seeds that are going to transform India, but rather it would be a collaboration like that India-Mexico seed that was developed, and not one which is a top-down history of the seeds in India. Thank you so much.
Thank you so much, Gabriela. This is a really, really fascinating subject, and the way you're exploring and unfolding it is just really really interesting. I think I can have a bunch of notes and questions here, but I guess we'll just move on and move on to our next panelist, who's going to be Marci Baranski. Hi, Marci. I'm also very pleased to meet you for the first time. I'd actually run into some of your work previously. Marci Baranski is an interdisciplinary scientist and historian working in the field of climate change mitigation in agriculture. And since completing her PhD in biology and society at Arizona State University in 2015, she has worked on climate change mitigation policy, research, and implementation in the private and public sectors. Marci published a book on the history of the Green Revolution wheat in 2022, Green Revolution wheat in 2022. And you're in Bangkok, is that right? You live and work in Bangkok currently. You're an independent researcher.
That's right.
Yeah. So I know for a fact that we have certain colleagues in common, and because I've had some work through UNESCAP and stuff. So
Okay.
we have colleagues in common, and also some certain subjects in common in relation to climate change mitigation in agriculture. So Marci, anyway, I could carry on with this very selfish conversation, but please go ahead.
I'll take it away. Thank you. And thankfully, I'm in Michigan today, my home state, visiting family. so the time difference is not too great, although I am still a bit jet lagged. But let me figure out, and unfortunately just working on a laptop, let me see if I can share my screen adequately. Okay, is that okay?
That's good. We can see it. Yeah.
Okay, great. So I'm going to be, first of all, I want to say I'm really honored to be here with both Gabriela and Rajeswari, who I actually did meet when I was doing my research back in 2013. So it's really just an honor to be on the same panel with such distinguished speakers. And thank you so much for the organizers for putting this together. Today, I will be talking about India's specifically wheat revolution and how this has shaped or become a model for international agricultural development. This is based on both historical and social science research that I have conducted and recently published as a book. And yeah, I am working for an international organization, but today I'm here representing myself as an independent scholar, and my views are not representative of my employer. So the rapid adoption of green revolution wheat and synthetic fertilizers in India became a story of technology triumphing over poverty and hunger. However, this is a story that we know is flawed. We know that the Green Revolution was a complex social, political, and technological movement, but the dominant narrative of the Green Revolution is only about that technological adoption. This narrative shapes current and future efforts at international agricultural development. Today, many international development organizations focus on the scaling up of agricultural technologies as a solution to poverty and hunger. My book examines how this concept derives from the rapid adoption, or in today's terms, scaling up of Green Revolution wheat. Green Revolution scientists such as Norman Borlaug attributed this to wheat's wide adaptation, meaning that these varieties had high yields under many different conditions. And as Gabriela said, obviously there are some similarities in the climate between India and Mexico, but this wheat developed in Mexico also spread throughout South America, Middle East, North Africa, and could be grown in many different regions. So it was actually one of the first instances of a variety developed in one location that could really quickly be adopted in other locations. And this concept was really popularized by Norman Borlaug himself, who with this really transformed agriculture science from a local activity to a global activity. But my research shows that this concept of wide adaptation that he promoted was also flawed. It has been highly contested in agriculture science, and it is not a good model for agriculture research and development. Today, I'm going to focus on one particular issue, which I call the paradox of the Green Revolution wheat in India, which is that a few varieties became very popular in India in the late 1960s and 70s, but they lacked some resilience to different climates and different environments. So the question is, how is it both possible that these are widely adapted varieties, but they also lacked resilience to some specific local conditions? So Kalyan Sona and Sonalika were two varieties that were derived from the Green Revolution wheat varieties from Mexico, and they were selected in India, and they were released in 1967. They dominated Indian wheat production for over a decade and were adopted under most growing conditions, including spreading to the, at that time, non-wheat growing areas in the Northeast. These varieties really exemplified Norman Borlaug's research program, being wheats that were widely adapted. They gave pretty good yields in most environments, and they had high responses to fertilizer. But yet, Indian scientists were finding that they were heat sensitive. This is M.V. Rao, at the time the coordinator of the Indian wheat program, saying that, quote, varieties like Sonalika, Kalyan Sona suffered the most due to high temperature. On the other hand, locally bred or selected materials were least affected. that they required fertilizer. This is A.B. Joshi, an Indian wheat scientist, saying that, quote, farmers are not adequately fertilizing these wheats. Experimental evidence now clearly shows that the new wheat varieties, especially Kalyan Sona, should not be given less than 80 kg of nitrogen per hectare. And from the renowned irrigation and water scientist J.S. Kanwar, he found that these varieties did not necessarily require more irrigation, but they required more precise timing and amounts of water. So the question is, with all these caveats, can we really consider these varieties widely adapted? During the 1960s, Borlaug and the Rockefeller Foundation had promoted this concept of wide adaptation very heavily in India. And this was a shift from the earlier research, which was much more decentralized and locally focused. But Borlaug and others, such as his colleagues working in India, claimed that the widely adapted varieties still had superior or adequate yields, even without fertilizer or even without irrigation. Many Indian wheat scientists did push back against this concept. I write more about that in my book and my article. I won't go into it too much today, but unfortunately, they were not on the winning end of this overall shift in agriculture, in Indian wheat research specifically. But later in the 1970s, Indian scientists started to present empirical rather than anecdotal evidence that questioned the wide adaptation concept more concretely. So this is from a 1977 article from Buller, Gill, and Kara, saying that the general experience is that this variety, here being Kalyan Sona, has wide adaptability as it is grown throughout the world, particularly in South Asia, the Middle East, and North Africa. At the same time, it is known to be highly responsive to high fertility conditions. The wide adaptability of this variety, therefore, may not be due to its inherently greater stability, but due to its distinctly greater yield potential compared with previous commercial varieties. And this is the general consensus that Indian wheat scientists were coming to around this time of the late 1970s, were that these varieties were not necessarily widely adapted as Borlaug claimed, due to some greater, some sort of genetic concept of wide adaptation, but more due to just they're very responsive to fertilizer and gave somewhat adequate yields under most other conditions. In contrast, C306 was a tall Indian variety released in 1965 by Ram Dan Singh Huda, the celebrated Indian agricultural scientist. And this was presumably done under these more locally specific types of breeding methods. This was a popular variety for its good quality and its yields, especially under rain-fed conditions. And it was still a top-yielding variety in those rain-fed areas 30 years after its release. Yet Borlaug often maligned C306 using the diagram that I'm showing here. This is a fertilizer response curve showing basically the yield of 3 different varieties compared to increasing levels of fertilizer. And this was done at Pantnagar University in northern India. So this clearly shows that C306, starting at the lowest level of 40 kgs per hectare and up to, I think it's about 200, has lower yields and even decreasing yields at the higher levels, while Sonora 64 and Lerma Rojo 64, which, as Gabriela mentioned, were the Mexican Green Revolution varieties, have, you know, almost unlimited in yield increases. Of course, it does stop at some point. And Borlaug really heavily relied on this model to try to convince both Indian and international scientists that they needed to abandon these, you know, traditional methods and traditional varieties and adopt the high-yielding semi-dwarf varieties. But both in recent years, from my own research, the research of Kapil Subramanian, and also, we both uncovered research by the former Wheat Project Director, S.P. Kohli, showing that this figure doesn't tell the whole story. If you actually take a greater range of data, such as from trials at the time, it shows that C306 actually did better under the lower fertility or say rain-fed environments, as we might expect, as it was so popular under these conditions. And my own research shows that up to, under normal levels of fertilizer, so very few farmers in India would even have been growing at or over 120 kgs of fertilizer per hectare. So under normal levels of fertilizer, C306 had actually the same yields as the Green Revolution varieties. Yet Borlaug really had to sell his sell these varieties to Indian scientists and especially to the Indian Planning Commission to satisfy them that these varieties weren't just for the elite farmers, weren't just for the commercial farmers, but they could also benefit peasant farmers under these unfertilized and unirrigated conditions. However, as we have this quote from the quotes from 1960-70 proceedings of the All India Wheat Research Workers Workshop, it's a fun mouthful to say, they found that the Mexican wheats were superior under the intensive farming conditions, while Indian varieties were superior under average or below average conditions. And so it's actually been known for quite a while that this diagram on the right is not really showing the whole picture. And we also don't know what exactly were the other conditions of the experiment. And it just goes to show that the data and science is itself political, and that different ways of slicing and dicing the data, you can get different results. So in fact, when Borlaug was questioned about one of his varieties, which followed this identified trend of having high yields under high fertility, but relatively lower yields under low fertility, he responded that the variety here, talking about Sonora 64, is high yielding when grown under heavy fertilizer conditions and is properly irrigated, but it will produce lower yields generally when it is in the hands of the average farmer. And I'm sorry that my line on the figure, it was supposed to be highlighting the Sonora 64, but in this figure you can see this is a logarithmic graph showing the mean the site mean yield, which is an index for just the general condition of this experimental site, and then the yield of each specific variety. So in my book, I go into a bit more about this type of stability model and how when Borlaug was actually challenged by the scientists who did these models, but he kind of deflected and was like, well, we developed it quickly and looking for a certain grain quality, but it is quite instructive to see, and actually was quite shocking for me to see this quote from Borlaug that in the hands of the average farmer, it would produce generally lower yields. So Borlaug's research method became the standard for Indian wheat research. So I want to talk briefly about it. And the steps are as follows. First, you do breeding under high fertility and often irrigated conditions, although you may be doing shuttle breeding, which is breeding between two different locations. And Borlaug was extremely adamant about breeding under these high fertilizer conditions. He felt that scientists did not properly appreciate the synthetic fertilizer revolution that was coming, and that the varieties that they were breeding would just, as we know that they, at a certain point, the grain becomes too heavy and they fall over. And so all over the world in the areas that Borlaug and Simmet were working, he was really preaching to scientists that they needed to be breeding under high fertility conditions. And then there's the testing, which is most often done using multi-location trials. So that's just testing these varieties under a variety of locations, maybe a variety of different fertilizer amounts, and under both rain-fed and irrigated conditions. But the analysis is also important. Typically, what Borlaug was doing, and also what became the standard for the Indian wheat research system, is that varieties with the highest average yield and good disease resistance would be selected and released. And this is what scientists presume is selecting for these widely adapted varieties, which have good average yield over a set of locations. And in India, say the country is divided into a set of zones. So it's not variety, the average yield over the entire country, but maybe the Northwest Plain Zone or Northeast Plain Zone or a certain hill zone. And so what this means, though, is that varieties with that excel or have tolerance to specific conditions, say such as drought or terminal heat stress, these are generally not advanced in the trials because they tend to have lower yields under average conditions. And so while scientists assume this method will produce widely adapted varieties and that these varieties will have tolerance to climate change, new research, including my own, has shown that this is false. This method selects varieties that excel mostly under ideal conditions, but it rules out these varieties that are well adapted to, say, locally specific or suboptimal conditions, such that we are expecting to find under climate change, and in fact are seeing, especially in Northwest India, increased heat during the wheat season. So Indian scientists have, for the most part, now focused on breeding under these ideal conditions, and thus these kind of hardy varieties, such as C306, have not been developed for Indian conditions. And what this means is that Borlaug's research was also going in this same trend. And in fact, Keith Finlay, who was an Australian scientist who later worked for CIMMYT, wrote to Borlaug in 1966 that the selection technique used at present certainly allows the selection of widely adapted genotypes, but it also automatically eliminates genotypes with exceptional potential for yield, given the correct specific environment. Borlaug had actually considered Finlay as to be the CIMMYT scientist in India, but he considered Finlay to be too academic, and so he was passed over, but he was later hired by CIMMYT. So Borlaug just did not like Finlay's more academic or quantitative approach, such as using the diagram that I showed a few slides ago. So I just think Finlay is a really interesting character in this story, one who's been overlooked as really someone who also revolutionized plant breeding with his statistical methods that he developed. So I do encourage you, if you're interested more in that, to check out my book. Now, there have been some efforts to revitalize location-specific research in India, especially starting in the 1970s and throughout up to about the 90s, when various people realized that the Green Revolution varieties, although they were spreading to, like I said, the northeast parts of India, they weren't necessarily benefiting the farmers very much, especially in rain-fed areas. So there have been several initiatives, which I do go more into my book, but I did find this quote from the World Bank, very interesting review of Indian research around about 1975, saying that the common denominator of all the gaps identified in all types of research activity is the weakness of the link between the research and the actual needs of farmers in their specific location and environment. And specifically, this was a review of agriculture research. So there was a World Bank funded program that was developed in response, I assume, to this review. It operated, I think, for about a decade, but I really never saw evidence that these concepts were integrated into the Indian wheat program. In contrast, paddy rice research was a completely different, took a completely different turn of events. Researchers in India and also the International Rice Research Institute realized fairly quickly that, as a quote from this article, that quote, paddy breeding research must be decentralized to become location specific. And for example, the International Rice Research Institute stopped releasing named varieties and really tried to work more with the national and regional research centers in order to develop more location specific varieties. But in the wheat system, I really didn't see such a shift. And I think that's because Kalyan Sona and Sonalika and the other shifts that happen in the Indian research system, they just really codified this idea of wide adaptation. However, And no new varieties like Kalyansona sonolica for irrigated or C306 for rain-fed cultivation have been developed. This is as of 1986, but I think that you could make an argument that even past that, there haven't really been these super blockbuster, widely adopted varieties, with the exception of PB343. This was derived from cement material in the 1990s. And I do think that the success of this variety really revitalized the search for wide adaptation in wheat, both in India and at CIMMYT. So in conclusion, I will say that, of course, we need to move beyond the Green Revolution model. And both in India and in international agriculture research, we know that the Green Revolution model is highly prevalent. And as I said, it's really focused on the technology, adoption of the technology, when we've left behind some of these more social and political factors that have simultaneously occurred to reduce poverty and reduce food insecurity. And I just argue that we've really learned the wrong lessons from the Green Revolution, especially around this concept of wide adaptation. And I do think that the so-called widely adapted wheat and the adoption of synthetic fertilizers together in India and many other places is a bit of a historical anomaly and a bit of luck on Borlaug's part that is unlikely to apply to some of the issues we're facing today, especially around climate change. And so my biggest takeaway lesson is that we have to recognize the context-specific nature of agriculture and that we will seldom find these one-size-fits-all solutions in agricultural development. With that, thank you very much. And yeah, really, once again, thank you for having me here today.
Thanks so much, Marci. That was really, really great. And I'm very glad that you, the way you wrapped up, reminding us of the issue of context-specific agriculture and climate change. These are two of the things that I think are going to, I hope, drive some of the discussion a little later. So thanks very much for that. Okay, let's move on then. And I guess since we're missing one of our panelists, I'm being a little more flexible in my own sort of time frame here. And we're moving on to our third and final panelist now, Rajeswari Raina, who is professor with the Department of International Relations and Governance Studies at Shiv Nadar University, now recognized by the government of India as Shiv Nadar Institution of Eminence. Her research goal is to understand and explain the interface between development, environment, and knowledge, science, technology, STS relationships, politics of knowledge and innovation, and the substantive relationships that underpin agriculture, human and ecological well-being are central to her research, which spans teaching and advisory roles within government, governmental, and civil society organizations and networks. She is an active member as well of domestic and international networks on rain-fed agriculture, rural and agrarian studies, agrobiodiversity, rural innovation and livelihoods, and the recent National Coalition on Natural Farming. The latest work and publications are on mobilizing public support, institutions, and piloting living soils, which is something actually quite close to my own field research interests, if I may say. Inclusive innovation, decentralized agroecological systems, revisiting international environmental assessments, and knowledge-based bioeconomic capabilities. These all draw and reinforce post-growth opportunities and environmental justice options, and partnerships mark all these endeavors with civil society organizations, environmental social activists, academics, donors, and positive deviance among policymakers. Professor Raina's work reveals that the plural meanings and materiality of agriculture are not alternatives. They are substantive, complex systems that are still holding out against the new fundamentals of growth and structural transformation promoted since the 50s. I'm really thrilled that you're here with us in this panel. It really is an honor to have such a distinguished number of speakers in this panel, among whom I really am thrilled that we have you to present to us today. I'll let you get on with your presentation, Professor, and we'll hopefully have an interesting, stimulating conversation later.
Thank you, Mondragón, and well, I'm really delighted to be here. Am I audible? Is it? I don't know. Hello.
Yeah, we can hear you, but are you trying to share the screen?
No, I'm not going to do a PPT. Sorry.
Oh, great. Okay. Okay.
So I just speak for about 12, 15 minutes. Decided, and we'll take questions after that because I'm not going to do a PowerPoint presentation. So again, thank you very much to all the organizers. It says here just to say that this is a brilliant idea, and I'm so glad that this is happening now. I mean, we should have done this at the Green Revolution history at 75 years. So anyway, glad it's happening now. And I'm also really, really happy to hear both Gabriela's presentation and Marci's presentation, which really speaks to a lot of issues that I'm going to address here. I'd like to begin with one, focus on the sciences. That is, I'm not going to speak about the seeds in particular, but about the sciences and also about the, let's say, Green Revolution, of course, as a revolutionary jump in yield, right? So we all think about the particular, actor, the plant that gives us this revolutionary jump in yield. There's a whole host of other actors. We heard Octavio Paz's concerns about Mexico and India and relationships, cultures, food cultures, what these civilizations meant, the meanings of agriculture that they had lived with and still live with for ages now. So I'd like to focus on one, the changes in the sciences, because of the Green Revolution, focusing on one, the natural and biophysical sciences. So what we call the agricultural sciences. You close your eyes and think about it. All of us will end up thinking about plant breeding and genetics, and now maybe mitochondrial DNA or genetically modified crops or something. Not about a whole range of other natural sciences and physical sciences, biophysical sciences that have actually built this corpus of knowledge that we call the agricultural sciences. So what happened? Why this dominance of one particular, let's say, strand or discipline or way of doing research, right? Which is basically about the plant, or let's say one particular element in this entire complex of sciences. So I'll talk about that. And two, the whole social sciences and humanities. The Green Revolution as a socio-economic construction, and the knowledge politics involved both at the regional and national level and also at the international level. So I'm going to talk about a bit about that too. And the key question that I have is, at a time, today, climate change and all these problems that we face, agriculture as one sector that has transgressed, violated, I think 6 out of the 9 sacrosanct planetary boundaries that we should not, at a time when the agricultural sciences should be at the forefront addressing these questions, we are still estimating things like emissions from such and so on, instead of studying what Vernon Rutten, one of the, let's say, most ardent advocates of the Green Revolution when it was on, now tells us in 2005, his lecture today to the Philosophical Society of America, I think, where he speaks about how the life science-based approach or paradigm in agriculture, that is in the agricultural sciences, has reached a point of diminishing returns. What we need today, he says, is a kind of knowledge system that will build secure bridges between agriculture and the environment, and agriculture and health, not just human health, but planetary health. So at a time when we need that kind of science, you look at the agricultural sciences, the agricultural science establishment anywhere in the world, but India in particular, partly because that's the system that I know best, you find that there's hardly any work on questions of relations and interactions, on questions of how, for instance, farmers make their decisions about what to grow, what not to grow, what will sell in the market, and so on. based on an understanding of yield per hectare, yes, but also yield per hectare per mm of water. But what kind of inputs go into it? So yield per hectare is one standard measure that's been given to us now. But farmers make their decisions based on several other factors that go into, and again, their meanings of yield is also different. Right? We've heard a bit of that in Marci's presentation too. So at a time when, especially, well, Latin America in particular, Mexico, yeah, greatest contribution that we have today in terms of, well, let's say, agroecological understandings about an agroecological way of living. It's not just about production in terms of, well, yield per hectare, right? But a different understanding of productivity at a time when so many interesting things, again, demanding things are happening, where the sciences should be investing in it. What are the agricultural sciences doing? That's the question that I'm trying to ask here. And two, also, I mean, the focus on the sciences, let me just legitimize it once more. One, as the most international amongst all human endeavors, but also this, let's say, feeling a little sad about the sciences. The scientific international is something that we see as, I mean, let's think of these great Solvay conference and whatnot, yeah, at the beginning of the previous century, our own Meghnad Saha and others sitting with Einstein and whatnot, yeah. We see the scientific international as, well, in some sense, simultaneously powerful, extremely powerful, and also highly vulnerable, highly susceptible entity, susceptible to capture by a particular kind of global narrative that can be created and communicated widely. The brilliant presentation that Gabriela gave us now points exactly to this point. That is, here is food, it is grains produced by a particular country coming to another, and there's a big effort to promote these seeds here. And all you hear is Borlaug and Borlaug and Borlaug, right? So this is the way in which, well, a particular kind of narrative can be constructed and well, communicated widely. So I'll also try and take the focus away from seed, yeah, which is what, again, the Green Revolution discourse has all been about, right? And focus on certain other things that the sciences have done. So let me begin with 2 lemons, yeah? The 2 lemons that you hear in India, I'm just kind of quoting from a couple of, government reports that you hear from 2000, 2007, 2008, and so on. So one is this lament about agricultural sciences being afflicted with a kind of isolation or detachment from rural reality, and instability in inability to acknowledge or lack of response to agrarian crises, and several other resource and market problems, and a consistent commitment to internal norms of hierarchy, exclusively upward accountability. One narrative, yeah, sad story about agricultural sciences. The second is from another document from the Government of India. It is necessary to take a comprehensive view of the functioning of agricultural research systems and make systemic changes in the course of the 11th plan. This is being written in the 10th plan, yeah? 11th plan preparation. So one, that make systemic changes in the course of the 11th plan. Thus far, I'm continuing the quotation, thus far, research has tended to focus mostly on increasing the yield potential by more intensive use of water and biochemical inputs. Far too little attention has been given to the long-term environmental impact or on methods and practices for the efficient use of these inputs for sustainable agriculture. These features are widely known, but efforts to correct them have not been adequate, at any rate, have not made much of a difference. It's a Government of India report. Now, what is really wrong with the agricultural sciences? Is it because they don't know? Or is it because they don't want to? My answer is they don't want to, right? And let me just legitimize that with a few things that have, let's say, a few changes that have happened in the agricultural sciences because of the Green Revolution, right? Because of, let's say, this revolutionary jump in yield, yeah, that happened in the 1960s. In one particular, well, we heard Marci speak about rice and wheat. Rice was very different, but somehow we've converted rice and almost all other crops also into the same mold, right? Put them all into the same box, into the same square, right? So what has happened over the past 4 decades, that is the knowledge content that has given the Green Revolution, that has kind of driven the Green Revolution after it was launched. We just take a look at what has, let's say, what has changed. Yeah, actually, 8 decades, but just to cover what we've seen as changes in since the 1960s here. I'm kind of going to list about 8 of them. Yeah, one is we've seen research that was, well, multiple crop livestock systems, livestock research, because India has a history of agricultural research, beginning with veterinary research for the armed forces, that is research on camels and horses that the British Army needed, right? So we had a whole range of research of that sort. Again, very, very, very focused, very highly focused on local high performance, that is location-specific high performance. Jonathan Howard's work also talks about it, how the British scientists who came here to study India, to work on Indian agricultural science, it was not agricultural science then, because Britain did not have an agricultural research system till the 1910s, right? India had an agricultural research system in the 1860s because the colonial government wanted one here. Back home, laissez-faire, whatnot. It was, just to take a little deviation. It was, as the story goes, a sleepy Parliament House that gave, well, what was called the whiskey money, taxes raised from that, to, well, you can spend it on agricultural science. It was just the Development Commission gets money, public money, for agricultural research in Britain much later, after it was done in India, that is, the agricultural research, public research system was established in India. Now, the changes that happen in the Green Revolution period is what we are focusing on now, right? It is from multiple research, let's say, contents and locations focused on the local problems, on building scientific principles based on these and so on. We moved to serial-based monoculture research across the board, right? Now, if you do not do this kind of research, if you want to do something else in let's say, varietal improvement or any other thing that you want to do, you will actually be discredited, yeah, either not promoted or, pushed to some corner of the country where you can't do any research anyway. So that's one point. That is the kind of shifts that the agricultural sciences have seen. The second is about the provincial research stations to centralized research councils. Marci mentioned this too. It is, we had a range of, let's say, research organizations. We've converted all of them in India into one particular, well, let's say, centralized consolidated council. This is a Marion Parker Rockefeller Foundation, the head of the Rockefeller Foundation in India. His recommendation to the government of India to bring in a direct line of authority and control to enable the Green Revolution research to be carried out in this country the way it should be carried out across the board, all through the country, right? So the centralization and consolidation of scientific research under one particular council, the Indian Council of Agricultural Research, which was a tiny little entity, which was really not even, well, let's say, counted as a research entity. It was kind of like a post office disbursing a little money levied from, well, the AP cess, the agricultural produce cess that the colonial government had. Yeah, it was not even a research entity. The IARI that Gabriela mentioned is actually one of the research institutes under the Indian Council of Agricultural Research. So the ICAR suddenly becomes very big in 1965. Reorganization becomes the agent or the actor under the Ministry of Agriculture to take over research. So this kind of, well, let's say, centralization and consolidation is also a result of that Green Revolution push. The third is about, well, higher education for rural development, which was what the University Education Commission in India had prescribed. And in 1946 to 48, the debates about university education saying, why should rural education be different? And, well, what should it contain? It entailed everything. It contained all kinds of things, physics and basic sciences and all that. Why should rural India be deprived of good scientific research and scientific education, right? So there was a lot of emphasis on learning, but also on the local crafts and engineering skills and all these things that rural India needed. We moved straight into a model act for agricultural education, and we institutionalized, as Lawrence Bush in his review done for USAID about 20 years after the agricultural universities were established, we established state agricultural universities in about, almost 84% of these were established in the districts that the Rockefeller and Ford Foundation were already working on their own, what's called the intensive agricultural development programs. It is basically high irrigation intensive and high chemical using areas, right? So the structure was transferred, not the philosophy of land grant. Yeah? Land grant colleges came from the US and were established here. That's the third point. The fourth shift, which is important, I'll take a little more time here because we've heard Gabriela's brilliant presentation on Borlaug. I can't help myself but say a few things about this. Yeah, the shift in the content of science. Here we're talking about the content of, well, the content of scientific research. What did an experiment in, well, agricultural improvement and agricultural, well, yield enhancement or pest resistance or whatever, what did it contain before the 1960s? And what did it contain after the 1960s? You see a major shift, again, very consciously built, a shift from horizontal resistance building and defensive research to offensive research, that is, response to specific inputs. Yeah? So we see how the content of science, the ways of working in science and the content of science was changed. That is, norms were made to make this shift possible. Now, we have to take a look at, again, this is archival material that I collected from the Rockefeller Archive Center about Norman Borlaug's work, but about others too, but mainly I fully endorse what Gabriela is saying, because here Norman Borlaug was handpicked by Eric Stackman. Eric Stackman is somebody, a mycologist who worked in India in the 1940s. He goes back to, because Rockefeller is already setting up, irrigated experiment stations here and experimental facilities here, chemical inputs here, and so on. Because again, contrary to what most of us imagine, is a popular imagination of the Green Revolution is that of seeds, but it was actually the irrigation and chemical inputs that came first. The varieties came much later, almost 20 years later, right? So Norman Borlaug is chosen by George Harrar and Eric Stackman to head the Mexican wheat program. 1944 it was established, yeah. And well, the focus of the program then was not plant breeding. The focus of the Mexican wheat program was on soil development, on plant pathology and wheat and maize production, right? And Borlaug was a brilliant plant pathologist. Let us remember, he was not trained to be a plant breeder. He was a plant pathologist, and he was testing fungicides in DuPont at the time. So he drew Stackman's attention in a wrestling match, and Stackman recommended him for the new job. What is the new job? The new job is, well, to send Borlaug to the third world with these new seeds. And, well, since he would fight to the last, I'm quoting from Stackman's memoirs, Rockefeller Archive Center, where he says Borlaug would fight to the last ditch and had real determination, which was something you would need to undertake a new job, a pioneer job in Mexico, and to take this, well, this particular attitude this person had, the scientist who had fortitude and perseverance, the missionary zeal to take up this job. Yeah, that is, you have to go out and change the Latin temperament, yeah, to make it the Anglo-Saxon temperament, orient the Latin temperament or reorient the Latin temperament to the Anglo-Saxon productivity drive, responsiveness to, well, the inputs that you apply, right? That you see. So we now know what happened, that the rest is history. We've heard today also. Now, the Latin American and the Asian temperaments were changed. We know that it happened. And in India, happened happily, because a lot of Indian leaders, Indian scientists were with Borlaug in this, and the Latin American and Asian temperaments were changed, and we heralded the Great Revolution. So this is one way in which the content of science changed. We'll get back to this. Do I have another 5 minutes?
Yes, you do. Go ahead.
So, the next set of changes don't really have to do with the sciences, but it has to do with the way in which the sciences were, well, let's say, moving out to the public, right, through technologies. Now, what India had at the time of independence was in rural India, you had a series of, you had this, what's called the CD program, the Community Development Program. Yeah. So community development programs had a village level worker who would, well, be a kind of jack of all trades, who would, well, deliver local services, help people with local problems, and so on. From there, we moved on to a set of very, well, siloized, or let's say very narrow departmental modes of functioning. And in agriculture in particular, these were converted to specific technologies, inputs, and supplies. That is a role of the Department of Agriculture, is to basically supply inputs. Yeah, and of course collect data during the crop cutting experiments. I mean, the crop cutting surveys that happen at the end of every season, right? So that is, you've converted a set of, well, let's say, state capacities from, well, working with people on local problems to, well, supplying, in most cases, embodied technologies, yeah, and collecting data, yeah, for the state. The sixth one is the sixth major shift is in the social sciences. We know that local markets, very, very active in this country, as in Mexico. The local markets, I mean, we've seen work by a whole range of actors in Mexico. Brilliant work, David Barkin's work, for instance, about how many of these local markets, local consumption patterns have been changed to, well, let's say, an international understanding of markets. It is at a market price that is fixed at the exchange value of a particular commodity. We've robbed people of the meanings that they gave to markets, of the kind of, well, use value, communities of affinity that work within a local market. We've removed all that. From there, we've marched on with well, let's say, decades of minimum support prices, farmers protesting for these or bargaining for these, to Food Corporation of India, the public distribution systems and global trade systems. India now exports massive amounts of rice. India is the largest exporter of rice today, but we still have hungry people. We have the highest number of malnourished people in the entire world country. Why is it happening if we had a successful green revolution, right? So it's because of this shift. Again, this shift is also a result of, again, there's a lot of material on these processes, some of which, well, I've done, but some others have also done really, really great work on this. The seventh piece that we want to look at is, well, from local inputs, local biomass, local crop livestock systems and crop residue that would come back to the farmlands as manure. We've, of course, moved to industrial inputs, yeah, chemical, mechanical, financial, biological inputs that come from industry. The problem today that industry finds absolutely, well, let's say, unbelievable is that industry has not been able to take over, well, 80% of the value added in the biological inputs yet. Because biological inputs, seeds in particular, are still with farmers. Land races are now going through a major revolution in India. Land races are being collected and saved by local people. I think this whole experiment starts in Bolivia. We learned from this. A lot of our own researchers, civil society actors learned from people who started with Bolivian collections of potatoes and corn and so on. And we've now taken this forward in India too. We have major collections of local land races by a lot of local participants who now exchange seeds amongst themselves. So that major shift is another major, well, let's say, from local inputs to industrial inputs, right? The last bit, there's a last major driver of change, or the last major, let's say, shift in the content of knowledge is in, local irrigation or a little bit of moisture, adding a little moisture to the soil when the crop is under stress, rainfall dependent agriculture, to irrigation, that is massive irrigation structures. At one time, the first few decades of after India's independence, India spent about 90% of, or let's say 90% of public capital formation was for irrigation, large dams and canals, right? Now it's become more private capital because it's all private irrigation equipment, bore wells and so on, and also with subsidies. Yeah, so public subsidization of private investment is also growing in leaps and bounds. What does this mean? This means that the content of science in understanding water systems, the content of knowledge politics of water, is something that has also changed, again, driven by the Green Revolution. Yeah? We heard Marci speak about plant breeding protocols, varietal testing methods, and so on. You look at all these 8 points that we've discussed today, that I've presented today. In all of them, certain protocols have changed. Protocols to, well, let's say, govern the content of knowledge have been transformed because of one particular, well, let's say, experiment to enhance yield at a time, the 1960s, yeah, at one particular point of time. Why haven't the sciences changed? Is it because of lack of opportunity? As Ratan says, Vernon Ratan, I quoted it at the beginning of this presentation. Vernon Ratan, again, most of you must have read his work. One of the leading economists who celebrates the Green Revolution, celebrates the revolutionary jump in yield that we've achieved. Models of development, models of agricultural development. Ratan's, of course, the high payoff input model is what is Ratan's exposition on that is what is accepted by countries throughout in all these newly independent developing countries, the 1940s, 50s, that launched the Green Revolution. What we see today is the inability of the agricultural scientists to wake up and question the norm making that happened in the 1960s and 70s, and, well, work with local people who've actually been doing very, very interesting work. Yeah, very interesting work studying relations, as Ratan demands. Yeah, relations between the environment and agriculture, relations between agriculture and health, human health in particular, but also planetary health. Now, the fact that this ability to work on relations and interactions, as many of us would have been exposed to, is being celebrated as one of the biggest, well, let's say, quests today in all the studies that focus on social ecological systems. Yeah, social ecological systems frameworks as people, well, let's say, the everydayness of it in some sense, yeah, is something that still keeps, well, agriculture in tribal production systems, agriculture in several multiple cropping systems that India still has, and Mexico still has too. I just want to end with this, that there is a need to reinvent and revitalize the sciences themselves, the agricultural sciences in particular. Yeah? And that is something that we need to focus on. Again, moving out of, as Gabriela says, beyond Borlaug and beyond certain, well, let's say, convenient, uniform norms of scientific research that were constructed in the 1960s and 70s. We need to move out of that and revitalize ways in which the scientific, again, not just the natural sciences, but also the social sciences and humanities. Yeah, humanities in particular, because the Green Revolution itself, as my colleague Sambuddha would say, is one of the biggest metonymic shifts that you find in the English language, right? So we know how these things are constructed. We need to find a way of getting back the language and the science to deal with these questions. That is the question of a sustainable and healthy future for all of us. I hope this well, let's say, the series will help us get there. Thank you.
Thank you so much for that. That offers us a kind of a broader, a kind of panoramic commentary on a number of things that I think we can now develop in our questions and answers. I don't want to take too much time here, but I guess I'm just going to throw out a number of items for the panelists to answer. I'm going to go in order here of the presentations. I was thinking especially about some of the, taking some of what has been presented and trying to think, on one hand, what it does for our reimagining, reconstituting the narrative of the predominant narratives of the Green Revolution, and on the other hand, what kind of lessons it derives for what we're doing today in certain areas of research. So I was thinking, going to Gabriela's presentation, I mean, I really enjoyed it, and I think it's very fortunate that you have Octavio Paz as a kind of observer, a sort of what did you call him? He called himself a narrator. What kind of narrator was this? A keen narrator, you said, of a country in transition. He was still operating. So this is a bit of a kind of a commentary and a sort of provocation for you to develop on. So he was still operating, what I was thinking is within a kind of modernist narrative, except it wasn't economic, it wasn't political, it was culturalist. But it was very much informed by the culturalist frames of the nation and the regime at the time. I was just thinking exactly, precisely in those years, you have a number of processes and events going on that are kind of indicative of where this narrative was moving and how it was taking shape. One thing that just jumped out to me was the foundation of the National Museum of Anthropology in 1965. Of course, this was a major event and a milestone in how the narrative of the cultural and historical narrative of the nation was taking shape, and this foregrounding the whole issue of great ancient civilizations and the indigenous roots of the nation state as it was taking shape under that regime. The other is the non-aligned movement and how that was coming together as an alternative to the global Cold War and the sort of bipolar or polar big power world. And I was thinking, you have a picture there with Lopez Mateos and who was it, Gabriela? Remind me.
Nehru.
Nehru, of course. And I was thinking also, there's a very important transfer of knowledge going on between, a sort of technical transfer of knowledge going on between Mexico and Indonesia at the time, except it wasn't agricultural, it was electoral. And it also involved Lopez Mateos and Sukarno. So there was, what I'm thinking is, these various different countries in the global South, as we understand it today, we're engaging in these kinds of diplomatic transfers of technical and technological knowledge, but very much within the framework of a slightly authoritarian, a slightly authoritarian framework, which still imposed a kind of epistemology, a kind of, in this case, technical knowledge related to agriculture development, national progress. And the most important item here, which of course, I'm just, again, this is a kind of provocation to get you to answer perhaps some of what this makes, what this can help us think about. Paz was basing you mentioned his having previously written El Laberinto de la Soledad, which was a very specific kind of characterization of campesinado, so rural people, agriculturalists, small farmers, and where they fit within that framework of the nation. And I guess what all this does for me is it helps to also think about, you're trying to rescue, you're trying to explore the sort of occluded or marginalized histories behind the transfer of seeds and agricultural expertise between India and Mexico. But there was a kind of second order eclipsing here of local and indigenous knowledge that was also, already being marginalized. Chapingo was built on what kind of technical expertise that completely eclipsed. It's funny because we often celebrate the whole domestication of maize as a kind of indigenous, almost prehistoric achievement, but then it's completely taken out of the picture there. Whereas today we would foreground indigenous and local knowledge when we're thinking about these sorts of things. I know I'll leave it there because I have a few more ideas in mind, but I wonder how if this comes into your thinking, or if that has anything to do with the way you want to take Paz as an interesting alternative to these other predominant histories.
Yeah, I think that's such a wonderful provocation, Carlos. Thank you so much. And I really think of what I'm trying to do as uncovering layers of erasure that are happening within this story. So Paz is just one, but we also have, as you mentioned, we have local knowledge, both in India and in Mexico. And Marci really made mention to this, as did Rajeswari, in terms of who's considered a scientist, but also what type of knowledges actually make it to the surface, so to say. So to think about, if we think about this story as one in which multiple layers of narratives have been maybe not necessarily erased, but not given a light. So I'm interested in entering to look at this through Paz, to look at also the local knowledges in Sonora when it came to the type of farming that was done before the experimental station was set there. And you mentioned something else that I thought was really interesting, that Paz is still thinking of within a modernist narrative of the nation. And I think that's really interesting because he's trying to find, and this is only on his memos, where he's trying so, and it's not so hard. He writes this wonderful book, In Light of India, decades later, and it's about his time in India and how much it allowed him to think about Mexico. And he's making these parallels between Mexican food and Indian food, curry and mole. I mean, but he's also about the people, the physicality, how Mexicans look like Indians, Indians look like Mexicans, and the long history. But it's not superficial. The fact that he's making, it's not light comparisons. What he's trying to show is that in this mid-20th century project of development and of developmental ideas, that there are other paths to progress, and that we don't need to, and he says this quite clearly, that we don't need to be stuck, as I said earlier, in a capitalist modality. But he is still working within, as you say, a nation state frame. And he's still working within this division of rural urban divide. So to reimagine these narratives, we need to begin to tease out not just because even within the embassy in Mexico, Paz was the ambassador, but he had several layers of people working under him. And they were sent instructional media to go to, so you had Mexican bureaucrats going into the fields with Indian farmers to teach them about Mexican seeds, which is something we normally don't talk about when we think about who is going into the fields. So I'll leave it there, but I just want to add that I'm in my hotel room and I've overstayed my time. So if I suddenly cut out, it's because this woman keeps knocking and I've asked for a few minutes. So if you see me climb out, I've overextended my welcome in this hotel.
It's terrible. No problem. Don't worry. If you suddenly disappear, we'll understand. Thanks ever so much for your replies. Of course, I think, always these sorts of meetings and panels always have limited time, but I hope we can carry on this conversation, you and others of us who are present here today. So thanks so much, Gabriela. If you suddenly disappear, we'll understand. And well, so this takes me to Marci's intervention, and what I really enjoyed about this, Marci, again, my biases here, my research biases have to do with local and indigenous knowledge, and I'm going to go really quickly here because I know that we have other people who probably want to put in their own questions. But what I like is that you are offering us an insight into the form that the specifics of this technical knowledge and how it comes together. So, what I like about the research that we're looking at today is that it's picking apart how the epistemology of the Green Revolution came together and how it was built up. And that offers a really great platform for contrast to what we look at today. So, if we take two of the concerns that drive my research, for example, which are to do with bridging local and indigenous knowledge systems and the co-production of knowledge for agroecological diversity and this and that, and then climate change. When you throw climate change into the picture, as you very nicely, when you were wrapping up, and as well in the readings that you sent us, you very aptly sort of direct us to this whole issue of agroecology and global climate change as being determinant to what in this case, I think you're talking about wheat production in India. What the future of wheat production will look like will be determined largely by this. I guess, I don't know, again, this is more a kind of commentary, but because it doesn't come into the Green Revolution picture, I wonder how you think about the issue of local and indigenous knowledge systems today in relation to what you're saying, because we've heard a little bit about climate change, this whole issue of heat and extremes, etc. How would you bring local and indigenous knowledge into this?
Yeah, thank you so much for your comments. I think the irony about my research is that I agree with everyone who says we shouldn't focus so much on the seeds, we shouldn't focus so much on borlaug, and yet that's what I do for maybe 2/3 of my book. But on the other hand, I didn't realize at the time, but that that at the time that I was doing my graduate studies was the first time that researchers were well, I think there was not the first time, but a renaissance in really studies of the Indian Green Revolution, and actually bring the voices of Indian scientists to the forefront. And luckily for me, they were speaking English, and their these wheat research workers conferences were available for me to use. And so that was part of it. But yeah, then once I finished my dissertation and started getting invited to, say, forums on agrobiodiversity, and it didn't, again, something I support and is working with Biodiversity International, but I didn't at first understand the connection. And I'm realizing, okay, so actually, I mean, wide adaptation in some ways is the enemy of agrobiodiversity, in that, right, making everything so homogeneous is actually physically reducing that agrobiodiversity. So now I understand the connection. And one of the things that also came to the forefront during my research was, yeah, just the erasure and de-skilling of agriculture knowledge in India. And I mean, and you've also had just the transformation, as I mentioned a few times, wheat not being prevalently grown in Northeast India. Now it is, along with rice, and even rice. I mean, rice being grown in the Punjab. It's not if you really had been there before rice was being grown, you wouldn't naturally say, yeah, this is the place where rice should be grown. I mean, it's adjacent to a desert. And so I think it is unfortunate that, yeah, a lot of that local and indigenous knowledge, at least for, say, maybe the field crops that were prevalently promoted during the Green Revolution, a lot of that is lost. And so what I would say, and I don't engage in this much in my research, but what I think one of the things I say in the conclusion of my book is that we should look to wheat as an outlier, and we do need to look to other systems in terms of local and indigenous knowledge, climate resilience, and that, yeah, this domination of wheat, widely adapted wheat, is, I think, is kind of an outlier in history, but it's still quite prevalent today. But there are so many pockets of knowledge of agrobiodiversity that we don't want to exploit, just using it and abusing it, but to work together with the keepers of that knowledge, and in starting to engage them in the traditional system. And that's a reasonable part of my book, is about how, and as Rajeswari has said, just the system of agriculture science in India, especially wheat science, is not set up to work with farmers. And I had many scientists say to me, well, I can't, say, work with farmers and release varieties to them, or work with the varieties that they're using because of plant protection laws in India. So I think that there does need to be some coming together between the kind of the Green Revolution model system and those sort of alternative forms of science and knowledge. I'll leave it there. Thank you.
Thanks so much, Marci. And by the way, I would say thanks for your, this 3/4 of your book dedicated to borlaug is precisely the point, is like, picking apart what's going on there, with this type of technical knowledge production. We really have to get to the bottom of that, because this allows me to get into a very brief comment on Professor Raina's intervention, which is to do with the repetition that we're seeing, about the repetition of expert knowledge structures being reapplied, as though current problems require the same kind of technical solutions that we were seeing in the past. And this goes back to a slightly old debate regarding the transition from, the critique of development in the 70s and 80s. And what we could say today about climate policy and climate change policy and the sort of solutions that are being applied to it very much mirror, in many ways, the kind of lessons that we didn't learn from this previous round of interventions and technical expertise being imposed on local systems. I guess I really don't want to take up any more time here. If we have questions, I haven't seen any on the, oh, hang on, maybe here it is. So maybe Diana, do you want to, or Nezahualcóyotl, do you want to read these questions, or shall I do this? How do you want us to?
You can do it if you agree.
Okay,
Thank
so
you.
we have a question here from Dominic Glover, who says, I'd like to ask, how conceivable is it historically that India could have followed a counterfactual history of an Indian Green Revolution that would have prioritized local breeding and local adaptation instead of homogeneity and wide adaptation? So a little bit of speculation on alternative history. I guess partly this would have to do with the broader socioeconomic systems in which this kind of technical interventions were taking place, and the idea of production and productivity. But that's for you guys, whoever wants to take this up.
I can take a first crack at it, but I would also really love to hear Rajeswari's take on it, because that's kind of the hidden subtext of my book, is that that the C306 Ramdan Huda Singh version of Indian agricultural research could have existed, but was basically steamrolled by the Rockefeller Foundation, the missionary zeal of Borlaug. But yeah, I mean, also it was very much a political question. And so I don't think it was entirely up to, say, just the scientists, but there was so much, right, interplay of the politics of the ICAR and the IARI and the Planning Commission. And so I personally think that as many other, especially Indian economists, have argued that India could have gone a more, instead of going for, say, the high fertilizer, high irrigation, high chemical route, could have gone for this kind of more socialist, sharing of resources, that could have been possible given the right allocation of resources. But just to play devil's advocate, I mean, the advocates of wide adaptation do say that one of the advantages is in countries that have less scientific infrastructure, you can go in and give them almost a ready-made variety. Now, I argue that that's usually not how it works. But in India, there was a very robust scientific infrastructure, not necessarily focused on wheat, but maybe that's not the route that we want to go, right? That wheat took the place of other more nutritious crops. You now have India importing quite a lot of the pulses and oil seeds. So, you can't do a counterfactual history, but I think given some of the political leanings and the scientific infrastructure in India, that it could have been possible, perhaps more so than many other locations during the Green Revolution. Rajeswari, I'm really interested to see if you have any comments.
Thank you. Thank you. Thanks, Dominic. Very good question. And thank you, Carlos. Yes, I mean, I'll just take a second to say that there is, reapplying the same kind of knowledge to the current problem is a big problem, and I hope we can get over that. Because even in agroecology, even when we talk about agroecology in this country, I mean, you have, Indian scientists and some bureaucrats also talking about, the standard, the conventional measures and methods, which is not what agroecologically is, let's say, done, right? And so your question, Dominic, I mean, one, it has to do with, it could have been possible, yes, but it wouldn't have been, what we now call the Green Revolution, that is India's counterfactual history. Yeah, could have been, let's say, what if you remember this imperial chemist, Augustus Volker. Volker, what was it, 1893, writes about some parts of Indian agriculture, the garden agriculture of Thane, of Coimbatore, of parts of, he says, are the best and far, far superior to anything in England at the time. In other words, it would not have been the Green Revolution. It would have been a very, well, let's say, grounded, as in very, very rich in local understanding. In other words, people or workers in that agricultural system would not be counted as what we in economics call, workers or laborers, but have been counted as knowledge agents, skilled people, as Marci just mentioned. The de-skilling is what we are worrying about, right? So they would have been counted as people who are vested with knowledge about, not just about the crop and crop production, or but about a whole range of things that relates agriculture to its rural and market relations. So it would have been a very, very local breeding would have been prioritized. In fact, one of Volker's recommendations, Volker is the first, let's say the first person to recommend an agricultural research organization structure for this country, or what was later to become a country, wasn't a country then, where he says the first 2 tiers must be local, decentralized, and the first tier, that is the basic tier, should be the tier that is managed and conducted, where research is conducted, adaptive trials are managed and conducted by farmers. So farmer to farmer learning, exchange systems, knowledge fairs, as he calls it. The second is where a little more, let's say, tuned adaptive research is possible with some formal, calibration or whatever that you want to do, but basically bring in all the equipment that you need for farmers to do these two, to handle these two. The third is the applied and basic research, which is the only thing that the imperial British government takes up in India, right? The first 2 tiers are never, ever, even today, have not been institutionalized. So I think it would have been possible, but it wouldn't have been, the way in which we still are, let's say, have tied ourselves into this Green Revolution language. It would not have been the Green Revolution that would have happened. It would have been a series of, let's say, plural other revolutions that would have happened. Maybe not revolution, but adaptation and evolution that would have happened.
Thanks so much. Well, this kind of, so we have a couple of quick questions, and we still have a little bit of time. So one of the other people in the audience, Jaime Ortega, asks, could you tell us more about how the history of the Green Revolution is taught and known in India?
Do you want to do that, Marci? Should I?
Go ahead. I'm not as familiar with this. Yeah.
The history of the Green Revolution has been completely appropriated, 100% appropriated by the Indian Council of Agricultural Research. The IARI, which Gabriela showed as one of the leading institutes under the ICR, it's a 100% ICR story. That's it. Everything else, before the Green Revolution, let's say 1910s, colonial era, a local rice variety like Aduturai 10, ADT 10 was taken for breeding, that is straight line breeding, to Indonesia. It became a big hit in Indonesia, right? So Aduturai, Patambi, these kinds of rice research stations, sugarcane, the noble canes, taken throughout the world, actually. Yeah? So these were all very, very good, let's say very good, as Marci was saying, very good research that was happening, agronomic and plant breeding, not just, let's say, offensive research, but based on what is best suited or best, let's say, flourishing in a local given environment, So that was possible. So there was the narrative that has changed is this appropriation, the centralization and consolidation, as everything and anything that happens in the sciences and agricultural sciences comes from the ICR, right? So that's the story that India has now.
Thanks so much for that reply. And we have a final question here, which todavía tenemos tiempo en esa work. Sí.
Yes, a little bit more. Yes.
Yeah, we have one. So So here's Carlos Reborati asks, and this is a question that obviously that comes up a lot in these kinds of discussions, especially when we start to talk about the importance of alternative systems and such. So that's all very fine and well, but how do we feed the 50% of world population which is urban, and can peasant or local technologies manage? I'll let either of you answer in whatever order you like.
Go ahead, Rajeswari. Go ahead.
Sorry, I mean, I'm just fresh out of an argument about animal feed. So let me take this. A third, I mean, I think more than a third of quality grain that we produce today is fed to livestock, right? It's given to livestock for feeding us human beings again. So there's one part of the story which is about producing more so that you can feed something else, which will come back as energy to us again. That's one. But two, the idea that we are being fed well because of this increase in production is wrong. Yeah? That production has actually come at a cost of, well, pushing millions of people to poverty. There is worsening conditions of, well, not just the local environment, but in terms of availability of employment, yeah, access to knowledge, access to, well, markets. Yeah? That is, I'm talking about the diversity of local markets that people were used to. So this production that we have today, there's this obsession with this, what again, great economists have called the high production potential that we have today, comes at a cost which is paid by, well, 50% that is not being fed today. Right? So let's say 832 million people, I think, who are not go to bed hungry as we speak today. So it's not because of, well, agroecological alternatives that are being promoted in the world that these people are going hungry. It's because we are obsessed about one particular way of production and one particular design of agri-food systems, not just about production, but about the whole range of inputs and outputs that come out of agriculture too. So it's the agri-food system that's responsible for this, not agroecology. If we get to the transition, I hope we will, people will be fed well and fed, well, proper food. In India, we do produce rice. As I said, we're the largest exporter of rice in the world. That is actually what is produced in Punjab, which is an arid state. Punjab is an arid state. It has less than 600 mm of rainfall. It has canals, it has produced rice. But what is produced in Punjab is actually starch and water, Punjab, Haryana, and Western Uttar Pradesh. According to the ICR, it is deficient in 9 major minerals and micronutrients. So feed people with the starch and water. If that's what we want, yes, I think we should continue. If we want proper food, we should shift to agroecological options.
Do you want to weigh in? Thank you so much for that. Do you want to weigh in on this, Marci?
Yeah, let me just briefly weigh in, which is, I think, a common critique of, right, agroecology is that, well, do you want to keep people peasants? Do you want to keep people producing low productivity food? But, you know, this argument of commercial versus maybe more locally adapted agriculture in India has been going on for decades. That on one side you had the high fertilizer approach, but in my book I actually show that even the Rockefeller Foundation scientists said that, you know, actually, right, if fertilizer had been distributed more equally using local varieties, you still could have had the same gain in yield. And the reason for such a focus on irrigation and fertilizer was to transform farmers into commercial farmers as they were in the United States. And that is really, yeah, one of the arguments by Jonathan Harwood. And so there is a big question about, do we want peasant agriculture? Do we want commercial agriculture? Right? Do we want agroecology? Do we want biotechnology? And my argument is just we don't have to choose between these two binaries. There's multiple paths that we can take, but as Rajeswari said, under the current model, we are limited to one path. And this is not just in India, but you see it in agriculture development in Africa. By cutting off those alternative pathways, we are limiting technologies that could be more peasant friendly, because a peasant farmer cannot adopt commercial technologies. They will become a commercial farmer. And so these are questions that countries need to ask. Do they want to promote commercial farming? Do they want to promote alternative livelihoods for peasants? Maybe some people, they just can't earn a good living in agriculture, especially if they're working on marginal land. But it's not, everything doesn't just come down to yield, to high yielding varieties, to fertilizer. There are multiple pathways. And I think we're just trying to open up the conversation to looking beyond the Green Revolution model. Thank you.
Thanks so much, Marci. I'll just as a kind of really brief concluding idea is this all makes me think of what part of the place where I work in the Southwest Pacific, in Vanuatu and Solomon Islands. Multi-crop subsistence yields up to 70% surplus. Most of that food is directed at ritual exchange rather than survival. It's ridiculously productive, as it were, on its own terms. So there's just one example of what you just mentioned, Marci, about alternative systems and the complexity that underlies them, which is what is completely erased when you get these other sort of monocrop, high market-driven high yields. Anyway, we got to go. Thanks ever so much to everybody. To our both surviving panelists, Marci and Rajeswari, I'm really honored again to have met you and to have been able to learn and listen to your ongoing research. I'm very much hoping to continue these exchanges or conversation at some point in different contexts. And thanks to everybody who tuned in. Pues ya estamos. Diana, Nezahualcóyotl.
Thank you. Thanks very much.
Thank you.
Thank you so
very
much for this interesting panel. It was an honor to learn with you.
Thank you very much, everyone.
Listo, Diana, Nezahualcóyotl, pues muchas gracias.
Listo. No, gracias a ti.
Muchas gracias a ti, Carlos.